Right, we're going to talk about using linear equations. This is lesson 4.7. And what we're going to do is we're going to use the point slope form of a line to model some linear data. You might find that using this form is a little bit more effective than using intercept form because you don't have to first write the direct variation equation and then adjust it for the intercept. We can just use some of our known points. So what we're going to do is we're going to look at this investigation about life expectancy rates. So this is looking at the relationship between the number of years a person is expected to live and the year in which that person was born. Life expectancy is a prediction that's very useful in the medical field as well as in insurance. And it's something that has a pretty linear relationship, but we'll see when we graph these points that, of course, it's not perfect because it models real life, which always has some chaos, which always has some like randomness built into it. So what we're going to do first is, so I have my table here. In this first column lists the birth year, and then the second column lists the female life expectancy rate, the male life expectancy rate, and then the combined life expectancy rate. So if you're following along, you can just choose one and plot those points. I'm going to go ahead and plot all of them just so we have that information. So I'm going to start with females. So let's see, cool. Okay, so the first one, before we begin, let's think about what will be our independent variable and what will be our dependent variable. So our independent variable is the thing that does not depend on anything else, that just happens without any input, without any, it's not reliant on anything. So that's going to be our birth year. So that's going to be the birth year. So that's the independent variable. That's going to be represented by the variable x, and that's going to be plotted along the x-axis, the horizontal axis. And then the dependent variable then is going to be the life expectancy. So that's in years. And that will be represented by the variable y, and it will be along the vertical axis, the y-axis. Okay, so now we can go ahead and start plotting these points. So I'm looking at birth year 1940, that's right here. The female life expectancy rate is 65.2. So that's going to be right around there. And then in 1950, it's 71.1. 71.1. 1960, go over to 1960 and then up to 73.1. That's going to be like right in there. And then 1970 is going to be here and then up to 74.7. 1980, it's 77.5. 1985, it's 78.2. 78.2. 1990, 78.8. They're all kind of around that same place. 1995, 78.9. 2000, 79.5. And then 2005, 80.4. So like I said, there's somewhat of a linear relationship here, but not perfectly, again, because we're dealing with real life. So I'm going to go ahead and I'm going to fast forward through, plotting the male and the combined points. Now I'm going to work through step 2. Now that I have all of my points graphed, I'm going to choose 2 points so that a line passing through them closely reflects the pattern of all the points on the graph. And then I'm going to use those points to write an equation for the line in point-slope form. So again, I'm going to look at the female life expectancy rate. So those are my green lines up here. And what I'm doing is I'm trying to choose 2 points. They don't necessarily need to be consecutive points, but I want them to be 2 points that shows a line passing through them that will represent all of the points. So like, okay, I could choose this line, but that's going way too high, right? But, or I could choose these 2 points, but that's a little low. What I'm going for is a line that is, again, that line of best fit, the line of fit that ideally we'd have an equal amount of data points above the line and an equal amount of data points below the line. So again, this one's a little low. Same with these 2, about those 2. That actually looks pretty good. Or even those 2, I like that. This I think is a little too horizontal. Yeah, I think I'm gonna go with these 2. With these 2, and I'm gonna draw my line. Okay. You know what, now that I do it, I see that it kind of goes a little too high. It goes a little too high, so let's erase. Okay, and what I'm kind of thinking now that I'm seeing that is if I choose these 2 points, that looks a little better. That looks a little better. I'm going to use that. So I chose this point and this point. That would be at 1980 and 1990. So at 1980, remember that's my x value, my x coordinate. 1980, the life expectancy was 77.5. That's my y coordinate. So this will be x1 and y1. And then the second point was at 1990 as my x coordinate, and then 78.8 as my y coordinate. So now this will be x2 and y2. You could have chosen any of these points though, and they would have given you, some are obviously going to be more accurate than others. But what we're doing here is a prediction. So no one really knows the answer. It's kind of up to you to choose, right? So now we're going to write this equation in point-slope form. Remember, point-slope form looks like this. Point-slope form is, let's not use the equals, so y equals y1 plus b, that's the slope, times x minus x1. So we're going to use this form to write an equation for this data, to model this data, right? So let's see. First thing we should do is find the slope. The slope is equal to, b is the slope, which is equal to the change in y over the change in x. So y2 minus y1 over x2 minus x1, which is equal to y2 minus y1 would be 78.8 minus 77.5 over 1990 minus 1980. So let's plug that into our calculators. Right here is a little more clear. Let's do 78.8 minus 77.5. and then divide that by 1990 minus 1980 is 0.13 equals 0.13. That's going to be my slope. So now I plug this in here to my slope, and now I'm going to plug in, let's use this y1 and x1 in place of this. I could use these two values instead if I wanted, but I'm going to use this. So that gives me y equals y1, so that's 77.5 plus 0.13 times x minus 1980. Right? And then that's my slope, or that's my equation for this data. Right? And again, I graphed that already. That's step 3, to graph the line. Does it fit the data? I mean, it fits it pretty well. There's this outlier. So I don't know, maybe I could have used something else, but really what I'm thinking is, like, if we're trying to predict something for the future, this seems to be a better fit than if we were to go, you know, if I were to include this line. Because it seems to me like, you know, that's a pretty big jump from 1940 to 1950. It went from 65 to 71. All the other points are, you know, have a lower rate of change. All right, so now my final step here is to predict the life expectancy of a person born in 2022. So what I'm going to do is I'm going to copy down my equation. It's y equals 77.5 plus 0.13 times x minus 1980. So remember, my y is my life expectancy, and my x is the year the person's born. So life expectancy and year. So if I want to predict the life expectancy of a person born in 2022, I need to just plug in that 2022 in for x, which would give me y equals 77.5 plus 0.13 times 2022 minus 1980. And then again, I just plug that right into my calculator. I get 77.5 plus 0.13 times 2022 minus 1980, which gives me 82.96. And think about it logically, is that a good guess? If we look at the table, right, I mean, the numbers keep going up, so we could expect that life expectancy will continue to go up as time goes on. But again, there's not really any way to check that answer, right? Because first of all, no one's been born in 2022, and even for, you know, and so therefore we can't know their average length of their life of the people born in 2022. But I would say that this is a pretty good guess. So what I want you to do now is, from Google Classroom, there are some practice problems for you to do, and they're going to look a little bit differently, look a little bit different than what we just did. But I think you'll find them interesting. They're real life situations, and these are going to help prepare you for your quarter 2 exam, right? So give these practice problems a try, submit your work, and please let me know if you have any questions or you get stuck. I'm happy to help, right? Hope you're having a great day. Thanks for watching.